Welcome to our deep dive into the MECHA C1 User's Guide, version 7.2.10. We're going to help you understand this high-tech device for precise and repeatable object rotation and movement. Before we delve into specific practical details, let's give you a quick overview of the device itself. The MECHA C1 consists of two parts, a motorized rotator, which performs the actual turning, and a C1 controller, which acts as the brains of the operation. The C1 controller is our first-generation controller, featuring LED indicators, a compact design, and a built-in, high-capacity battery for full-day usage. It supports USB power banks or regulated 5 volts, 2 amps direct current supplies for continuous operation. The C1 controller can control one MECHA rotator at a time and is the ideal companion for Nodal Ninja R1, R10, and R20 single-row panoheads. However, two C1 controllers can be assembled into a dual-axis combo configuration to control two axes, just like our C2 controller. Other MECHA controller C1 features include 3 buttons to run presets stored in memory, Wi-Fi remote control, in the 2.4 GHz band, from smartphones, tablets, and PCs using a web interface. Connection via a Wi-Fi access point for remote control over the Internet. Over-the-air firmware updates. A cam port to trigger camera focus and shutter release. Support for any camera with a wired remote release port. Multipurpose AUX port for commanding MECHA's start-stop and other functions with a wired or wireless RF remote. Commanding MECHA's various functions with a Nodal Ninja IR remote. Camera shutter release confirmation. MECHA can only trigger a camera's shutter. It functions like a typical remote shutter release. To enable automatic shutter triggering, plug the appropriate shutter cable for your camera into the camera port (CAM). You can mount MECHA on a standard tripod, and the really neat part is how you can control it. MECHA C1 offers two main control methods, physical buttons on the device and a web interface accessible from your smartphone or computer. Let's talk about those two methods in a bit more detail. The buttons offer a direct and tactile way to control the MECHA C1, a power button, directional arrow buttons for manual movement and confirmations, and numbered buttons, 1, 2, and 3. Think of them as your quick access shortcuts. Regardless of the control method used, MECHA C1 users should consult this table of equivalences, which outlines the conventions for displaying characters on the C1 controller LEDs. It serves as a quick reference guide for understanding basic information displayed on the LEDs. Initially, each numbered button corresponds to a pre-programmed number of shots around a central point. Button 1 gives you 4 shots. Button 2 gives you 6. Button 3 gives you 8. These are perfect for common panorama setups. So if you need a quick 6-shot panorama, simply press button 2 and specify the direction of rotation using the arrow buttons. No complicated programming is needed. And it gets even better, holding down those numbered buttons executes what are called favorite codes. MECHA's buttons also allow you to enter specific codes to perform simple and complex operations without accessing the user interface. So, the buttons are great for quick actions and frequently used sequences. But what about more intricate control? That's where the web user interface comes in. The web UI gives you a level of control and customization that goes far beyond what buttons can offer, allowing you to fine-tune every aspect of the MECHA C1's behavior. You can create and save your own presets for specific shooting sequences. And for those who really want to push boundaries, the web UI also provides access to what is called a raw interface, which allows for even more advanced control through specific commands. So you have two main ways to control the MECHA: physical buttons for quick options and common sequences, and a web UI for deep customization and advanced control. But how do you create those custom sequences or presets? The MECHA C1 offers multiple ways to create presets, catering to different user preferences and levels of complexity. You can use the buttons themselves, where the shooting pattern is computed by MECHA based on a few button presses without using the user interface. Or you can leverage the power and flexibility of the web UI, as we have already mentioned. There's even a method for programming presets using URL parameters. It's a surprisingly powerful way to define precise parameters for your presets. Another key aspect of the MECHA C1 is its firmware updates. We all know how important it is to keep our devices up to date. The MECHA C1 offers multiple ways to update its firmware, ensuring users always have access to the latest features and improvements. Now let's step into the world of the dual-axis MECHA, also known as the DAC. What's so special about having two axes of rotation? With a single-axis MECHA, you're limited to rotating on a single plane. It's great for simple panoramas and rotations. But if you need more freedom of movement, the DAC opens up a whole new dimension of possibilities. By combining two MECHA units, one for horizontal movement and one for vertical, you gain incredible flexibility. Imagine capturing a full spherical panorama, where you need to cover not just 360 degrees horizontally but also a wide range of vertical angles. With a single-axis setup, you would have to manually tilt the camera or the upper rail of your panohead for each row of the panorama. The DAC, on the other hand, handles those vertical movements automatically, allowing you to program precise, multi-row panoramas with ease. The upper rail of the DAC moves up and down, giving you that vertical control. How to actually use the DAC? Let's talk about setting it up. If you have two separate MECHA units, how do you get them to work together as a team? That's where the pairing process comes in. It's just like connecting your headphones to your phone via Bluetooth. You need to establish a communication link between the two MECHA units. The designers of the MECHA C1 have developed the ZLM2 method, which makes pairing incredibly simple. You start with both units powered off. Then, turn on the horizontal MECHA. As soon as you see the splitting lights on its LEDs, press and hold button 1 for a few seconds. You'll hear some beeps signaling that it's ready for a partner. Then, power on the vertical MECHA. As soon as you see its LEDs light up, splitting lights, press and hold button 2 for a few seconds. More beeps, and they're paired and ready to work together. How do you know for sure that the pairing was successful? Both MECHA units will display a specific LED pattern to confirm they are connected. The horizontal MECHA will have its middle LED on, while the vertical MECHA will have LEDs 2 and 4 lit up. If you see a red LED on the vertical MECHA unit, it means the firmware versions on the two units don't match. This is a reminder to ensure both units are running the latest software for optimal performance. Keeping your firmware updated ensures compatibility and access to the latest features. Now, how do you actually start controlling that dual-axis setup best? Just like with the single-axis MECHA, you have physical buttons and a web UI. Let's start with the buttons. In a dual-axis setup, the buttons on the horizontal MECHA controller still handle horizontal rotation, while the buttons on the vertical MECHA controller manage the up and down movement of the upper rail. It's all about coordinated control, so you can manually guide the DAC through any movement you can imagine using those buttons. But remember those specific codes we discussed earlier? They work with the DAC as well, but now they control two axes of motion. Starting from the parked position, it should execute a 3-row panorama, 12 shots per row, plus zenith and nadir shots. What if you want even finer control or need to create your own custom presets? Creating them with the DAC might be a bit more complex, but the core principles are the same. The web UI is especially powerful with the DAC because you can visually see the camera's position using the 2-axis slider when executing a preset. Once you've mastered the basic principles of preset creation, you can start exploring more advanced techniques. The DAC is essential anytime you need precise control over both horizontal and vertical movement. Before we wrap up this exploration of the dual-axis mecha, let's take a closer look at the different positions of that upper rail we've been discussing. Imagine the upper rail as a robotic arm in its parked position, pointing straight downwards. This is the most compact configuration for the DAC, making it easy to transport and store. So it's like the DAC is in its resting state. Now, when you move the upper rail to the level position, that robotic arm extends horizontally, parallel to the ground. This is a common starting point for many panorama presets because it aligns the camera with the horizon. It's a natural starting point for capturing a wide, sweeping view. Finally, in the raised position, the robotic arm tilts upwards. This position is useful for capturing so-called nadir shots. You can easily switch between these positions using the buttons on the vertical mecha controller. The guide explains the specific button combinations for achieving each position. With a bit of practice, you'll be able to effortlessly adjust the upper rail to suit your shooting needs. So you have 3 basic positions for the upper rail: parked for compactness, and also for zenith shots, level for those classic panoramic views, and raised for those nadir shots. Now, how do these rail positions relate to the pre-programmed codes and the custom presets you can create? Many of the pre-programmed codes for the DAC are designed for specific rail positions. The user guide clearly indicates the starting rail position required for each pre-programmed code and preset. The simple rotations we mentioned earlier play a role in positioning the upper rail. Simple rotations are an efficient way to quickly adjust the upper rail to one of its 3 basic positions: parked, level, or raised, without having to nudge it by continuously pressing the arrow buttons. Let's say you're working with a preset that requires the upper rail to be in the level position, but it's currently parked. You can use a simple rotation of 90 degrees to instantly bring the rail to the level position. These simple rotations not only save you time but also ensure that the upper rail is precisely positioned. It's a distinction between moving the robotic arm itself and changing the direction in which the motors are rotating. There's so much more to explore, but for now, we think we've given you a solid understanding of how the DAC works, how to pair the units, the importance of upper rail positions, and how to control those movements using buttons, the web UI, and simple rotations. Let's wrap up this deep dive with a final exploration of Mecha Simple Scripting, MSS, and perhaps leave you with a bit of inspiration. MSS is like a simplified programming language, but don't worry, you don't need to be a coding expert to get started. The user guide breaks down the syntax in a very approachable way. Let's look at an example of a classic multi-row panorama. You can specify the overlap between images, ensuring seamless stitching during post-processing. You can even specify the number of camera trigger signals at each position for HDR panoramas. There are many other settings you can adjust to meet your needs. Then, provide the focal length, and Mecha will create the MSS script for you. Once Mecha creates the script, you can save the preset and launch it to preview the movements without mounting a camera first. You can make adjustments if necessary, even incorporating pauses in the script for things like changing camera settings or waiting for the perfect light. The DAC will faithfully follow your instructions, carrying out the program sequence with precision and repeatability. We've covered a lot of ground, but not everything Mecha can do. Remember, the learning doesn't stop here. We encourage you to dive into the guide, experiment with the different features and control methods. Who knows what incredible shots and sequences you'll create with this tool at your disposal. Discover the magic of robotic precision and creative control with the MECHA DAC. Thank you for joining us.